Hi, this is a very interesting question. It says that a slide loving pig slides down a certain 35-degree slide in twice the time it would take to slide down a frictionless 35-degree slide. So we have two scenarios when the slide is same, the pig is same, one has friction, other is frictionless. So what is the coefficient of kinetic friction between the pig and the slide? Now we will make a free body diagram of the pig. We have the mass mg of the pig pointing downwards. And then mg will have two components, one which is pointing downwards across the slide, length which is mg sin theta, and you have mg cos theta, which is actually countering the reaction force of the slide surface on the pig. Now we know that frictional force Fs is going to be coefficient of kinetic friction mu k into n, the reaction force, and which is n is equal to mg cos theta, reason being there is no motion in the vertical direction. So both the forces have to balance out. So n is equal to mg cos theta, hence Fs is equal to the frictional force is equal to mu k mg cos theta. Now we will write the equation. Acceleration is in downward direction, so ma is equal to mg sin theta minus mu k mg cos theta, right? This is cos theta, okay. Now that means m we have removed, so we have a is equal to g sin theta minus mu k g cos theta. Now in case of frictionless slide, there is not going to be any friction, so mu k will be 0. So acceleration would be all same except that there is no Fs and there is only one force working mg sin theta in the direction of the slide surface and giving an acceleration ma. So ma dash is equal to mg sin theta, so a dash is equal to g sin theta. Now we will use equation of motion. Okay, we have distance is equal to velocity into time plus half into acceleration into time square, which is s is v1t plus half a t square. We will put these values. We are presuming that initial velocity is 0. So in case of motion on the surface with friction, we put value of a as g sin theta minus mu k g cos theta, right? Now this was in case of frictionless surface. So S1 is in case of frictionless surface. S2 is in case of frictional surface with friction, okay, which is v1t plus half a t square. Now this a and a dash has been replaced, but I hope you are trying to understand. You are able to understand, what we are doing here. So one is half g sin theta t1 square, other is half g sin theta in bracket minus mu k g cos theta, which is the acceleration into t2 square. S1 is equal to S2, so we can equalize the two. Now we have to see that how t1 and t2 are associated. Now half g sin theta t1 square means it's about the frictionless surface which has no friction, and half g sin theta in bracket minus mu k g cos theta is the one which has friction. Now we know that frictionless surface, obviously the flight is going to be taking lesser time. So t1 is equal to t2 by 2. Okay. So g cancels g on both the sides. So we get half cancels 1 by 2 cancels 1 by 2. So we get t1 square by over t2 square is equal to sin theta minus mu k cos theta over sin theta. I think now you are able to figure out what we are trying to do here. Now it has become very, very easy, pure arithmetics, and then yeah. So we are going to have more than 2000 plus problems here, so please subscribe the channel so that we remain connected and you get alerts, and thanks for watching. Okay, it has been pleasure solving physics problems here. Now we solve this and we arrive at mu k is equal to 3 by 4 tan theta, and here theta is equal to 35 degrees, so 3 by 4 tan 35 is equal to 0.52. okay, and so that was the piggy problem, very easy, and I think you also enjoyed being part of it. Thanks for watching. Yeah, bye.